We are live. I suppose I should bring up the YouTube. Anybody in chat? We did not get the video scheduled that far ahead of time, so I hope everyone's here. I'm sure everyone will filter in as needed. Thank you for joining us. Hope everybody had a good New Year. Oh, I see a few people in chat. Say something in chat if you can hear me before we get started. All right. So great. It works loud and clear. Hello. Yeah. So happy New Year. Welcome everybody. MergePHP 2024. We're kicking things off. We got a good serverless talk. So thank you all for joining us. And we have a shorter intro. So as you'll see here, the intro portion of tonight's entertainment will go quicker. So yeah, let's get started. All right, so MergePHP, this is us. This is all the user groups that are currently a part of MergePHP. You can see everybody's logos here. We started with 3 and now we're up to 10. So welcome everyone. If you see your user group, give it a shout out in chat. Yeah, the JetBrains giveaway, please email Chris at atlantaphp.org, and the first person to email Chris gets a free copy of a JetBrains product. So that's pretty good offer there. And we want to make sure that we use them. It's kind of a use it or lose it situation. So, tell your friends, tell your coworkers, yeah, who knows? We might have extras laying around occasionally. So, yeah, just email Chris whenever you feel like emailing Chris, and then, good things happen. So anyways, this is MergePHP. This is the new community logo page. Hope you all like it. So yeah. PHP support. Today is January 12th, January 11th, close enough. Yeah, you should upgrade your PHP. We are on 8.2. How many people in chat are still using 5.6? Maybe don't tell anyone, but
Correction.
I can neither confirm nor deny. I've heard people in the past recently admitting to using old versions, but please update your PHP versions. It is important. All right, so upcoming conferences and events. We've got Symfony Online in February, Laracon EU, that's an in-person thing in February, PHP UK in February. Lots of EU conferences. We got Dutch PHP conference in March, Laracon India in March as well. I believe all these are in person. Symfony Live in Paris, and PHP Tech in Chicago. So check out PHP Tech. San Diego PHP is the group responsible for putting that together. So that is definitely a great conference to check out. So check out PHP Tech in Chicago. It is a good conference, a great conference to go to. PHP Day is online in Verona, and International PHP Conference is also online in Berlin. So that's kind of the first half of the year. We've got probably some more conferences in the second half, but that'll if you're looking for something to do, here's some conferences to go to. All right, so Boston PHP, they do a couple different types of events. You'll see Gene Babin there in chat, and they do learning focused groups about once a quarter, and this quarter's is Career Essentials in Generative AI. So if you want to learn more about ChatGPT and the AI stuff that's happening, check out Boston PHP event there, and I'm sure Gene can tell you a little bit more about it. So ask Gene some more questions in chat since he's here. Yeah, all right. So you can find us here on Twitter and phpc.social, which is our Mastodon. And then please, if you haven't already, like and subscribe on YouTube. That definitely helps out us a lot. So that is the main thing here. If you are interested in speaking, go to this link here, mphp.io/speakers, and submit a talk. It's pretty easy. It's just a couple of form, you got to fill out. It's like 3 or 4 things there. And we're always looking for more speakers. So if you have an idea that is PHP or PHP adjacent, definitely check that out. All right. So our speaker tonight, Ian, he's been part of the user group for over a decade. Internationally renowned speaker, given conferences here in the U.S. and abroad. Is like runs Longhorn PHP, puts on his own PHP conference. There's a lot of other volunteers, of course, but he's very active in the community, and does a lot of things for PHP in general. Based out of here in Austin, is myself as well. And tonight we're going to be talking about PHP on Lambda with custom runtimes. So, what does that look like? There's some other services that you can kind of rely on. But if you want to run some custom runtimes on Lambdas, Ian's going to tell us all about it. There's a lot of different options in AWS and Lambda. Sometimes, it's easy. And I think this will be an interesting talk. So Ian is the man to talk about it. All right. So I'm going to stop sharing here and we're going to switch things over.
Go ahead and keep the slide
and
up.
If you have any questions for Ian as we go along, just post a comment in chat and we'll either ask him while it's going on or at the end. We'll kind of follow up with any questions. So thank you for joining us.
Yeah. All right, let me get my entire screen over here shared and then throw that full screen. One moment here. Do this. Okay. And you don't actually need to see me. Throw that there. Perfect. All right. So let's talk about PHP on Lambda with custom runtimes. We've done this presentation a few times since this feature has been available since reInvent, I think 2017 or 2018, actually 2018. But as time has gotten on, Lambda has improved in what it can do, and the tooling around it has improved as well. So if you've seen this before, maybe 5 years ago at AustinPHP, there are a few things in here that are new. Don't tune out just yet. And as almost always with my presentations. I will have tons of links to additional information in the presentations, and as well as some code samples and demos toward the end. Full disclosure, the current PHP 8.3 based runtime that I have pushed to GitHub, there is some sort of issue with that. So I'm actually going to be demoing off of a layer that I know that works, that I set up last year for PHP UK. The difference is under the hood, and I'll actually fix the layer after this, and either throw in meetup notes or chat or somewhere what I did to fix it. If it doesn't require a commit, if it does require a commit, then I'll push to the repo. Anyway, so we're going to kind of get into the weeds on kind of how Lambda works, what you would use it for, what it's good for, what it's bad for, and how it works in layering PHP on top of it. Now, that is a little bit less relevant information if you want to just get something up and running quickly, because you'll just use Bref or Vapor for that. And we'll get into that here shortly on why I recommend those. But understanding what's going on under the hood helps for potentially troubleshooting and understanding kind of why Lambda has kind of the quirks that it does. As part of that, we will look at a few demos. One of the main things that you'll do with Lambda usually is use it to tie together various other AWS services where AWS hasn't quite implemented the behavior that you need, and you need to take duct tape, baling wire, popsicle sticks, and Lambdas to fill in the last 5, 10, 20%. Potentially things like email processing or file processing on uploads and that sort of thing, which it's pretty good for. You can also hit it via HTTP. We'll talk through that. And lastly, we'll take a look at kind of the easy way to do things with Bref. So to be clear, we're not going to deep dive into how Bref ticks or how a serverless framework ticks, because I'm sure there are other presentations that you can see on those, and realistically, the things kind of just work for purposes of actually deploying something. We're also going to ClickOps our way through the deployment on AWS, at least with the direct Lambda stuff. Now, Bref uses serverless framework. That's all going to be at the CLI, but that's a very quick tutorial. Also not going to be fiddling with the ways of kind of running Lambdas offline, because you can generally separate your code out to where the pieces that are Lambda specific are insulated from everything else if you have a non-trivial application. Likewise, I'm not going to do a big old Laravel Vapor ad. You can look on their site and other presentations on that. Now, the big value proposition of Lambda is you don't have to manage servers, and you don't have to manage scaling of those servers. And you don't have to manage patching of those servers, and you can just more focus on the code that you're releasing rather than the infrastructure that it's running on. And the cool thing about Lambda is you can scale up and down, even down to 0, very quickly without a heavy penalty of like, oh, well, you scaled down to 0 and now it takes 60 seconds to start back up. No, that's not how Lambda works. When you have additional requests come in, they get served almost instantly. There's a difference between a cold start and a warm start, but not only do you get a massive amount of scalability, but you get an extremely fine-grained level of billing where you're actually billed per millisecond executed. So writing faster code actually turns into money. Now, there are a few quirks on Lambda where you'd think, oh, well, it's kind of this shared nothing function as a service thing. And well, it's not exactly shared nothing, and you can actually use that to your advantage to make things run even faster. But you can treat it as a sort of shared nothing environment similar to, well, standard PHP application. But again, there are some caveats there that if you're going kind of down to the metal, you'll need to be aware of so that you don't have kind of one invocation interfering with the next. Other nice thing again about Lambda is its level of integration into a whole bunch of AWS services. So if something gets uploaded to S3 or sent to SES or pulled off of a queue or a number of other things, there's usually a way to hook Lambda into that and process those messages without having to set up additional infrastructure. So those integrations, like the ones that we'll see actually in this presentation, we'll be dealing with S3 and SES. You can also pipe stuff from simple notification service, their queue service, or you can serve web requests a few different ways, actually. One would be placing Lambda behind an application load balancer, which if you have kind of other applications that are behind an ALB anyway, you can tell it, hey, based on this route or this host name, push this information to Lambda rather than, say, ECS service with Fargate or actual servers or what have you. But that's like $25 a month to start, and as your traffic goes up, then your bill goes up a bit on that. Another way that is more of a trade-off of kind of scale to zero is API Gateway, where you can set up a kind of single front end that is billed per request, which means if you have 0 requests, you spend $0 on it, and it will dispatch back to one or more Lambdas and then return the response to the end user. There are some nuances to why you would use a certain, like, you've got basically two ways of calling Lambdas on HTTP without something that costs per month in front of it. One being API Gateway, one being function URLs, which is a newer thing. But like both of them work. And API Gateway gives you a little bit more in terms of configurability, but has a cost to it, and function URLs give you less. There's fewer ways you can authenticate with them, and you have less control over host names and that sort of thing, but they're also free and, again, a little bit easier to set up. So now I skipped over one thing here on this slide, and that is that if you want to execute this little bit of code directly, you can just call an AWS kind of execute task API with your parameters and get the response back, or not get the response back and have that Lambda dispatch asynchronously. And that's handy for things like if you, to give you an exact example, for a while for a contract client of mine, there was a kind of new style encrypted Excel spreadsheet that we had to process. And that spreadsheet came in via email, and we'd run it through the main Laravel application. But for the decryption process, there's no real good library in PHP to do that. There is one in Python. So it's like, okay, well, we could install Python on the machine, and that'd be kind of annoying and maybe overkill and harder to maintain. Or we could set up a Python environment within Lambda, and for the couple of seconds that it takes or less to to pull the file and decrypt it and then hand the decrypted file back, you just run the Lambda for that, and your code is often compartmentalized, doing its own thing, and you're not having to deal with. You can basically deal with maintenance issues of either the code, which is like 8 lines, or the runtime, independent of the rest of the application. So, a couple of different ways of either serving by HTTP or serving in response to events within the AWS ecosystem. So I was giving you a lot of caveats on that whole shared nothing thing. The way that Lambda works is it'll start up an invocation, an instance of the function in its own little micro VM that is using something that Amazon developed called Firecracker. And it's really quick to start up, but you still have to kind of get the code downloaded and just various initialization steps set up, which takes under a second. But when you're trying to serve web requests quickly, under a second is not particularly competitive with just having a server sitting there ready for requests. So what AWS does is it'll set these Lambda instances up and then reuse them as requests come in. And then eventually they'll decide that they want the RAM back for some other Lambda customer, and they'll kick your process out, and unless you're consistently pushing traffic to it. Now, there are a few things that you can do to decrease the cold start penalty, and sometimes AWS will help you out by warming up Lambda ahead of time. And the weather map link that I have listed on here will show you kind of how long it takes to cold start in various regions, because it does vary a bit based on which runtime you're dealing with, and if you're dealing with something like Python or Node versus just the what they call a provided runtime that we'll be using for PHP. So we've got cold starts there. If an instance has been already set up, there is a /temp directory that can be used as a cache and reused when that same instance gets hit with an additional request. By default, that's half a gig. You can pay more money to get more space. Now, the thing with instances is an instance will serve at most one request at any given point in time. You're not doing parallelism inside that function, serving multiple calls off of it at the same time. If you have, say, 5 web requests come in to be handled by Lambda, that is going to give you 5 Lambda instances. Things like Google Cloud Run work a little bit differently than this, but in the case of Lambda, it's one function invocation serves one concurrent request. Now, over time, those instances will be reused. So one request comes in, one instance serves that in one invocation, then that request is complete, another request comes in, and if an instance is already set up, then AWS will route that request to the Lambda that's already warm, and you get your nice sub 10 millisecond response times in some cases. But at no time are you handling multiple requests concurrently on that same little bit of VM space, which means that in PHP cases, generally you're not going to want to throw more than one CPU core at a given Lambda. Speaking of CPU, the way that Lambda scales in performance is proportional to the RAM that you allocated. Minimum is 128 meg, and that Simple functions will still run okay on that, but it does get a little bit slow. And it maxes out now at a little over 10 gigs. That came about around the same time that Lambda started supporting pushing containers to it. You have a fine grain level of control over how much RAM you allocate, and CPU is proportionally allocated. 17 or 92 meg is the magic number where you get a full core, assuming you can max that core out, which you probably can't. But that's kind of the magic number for a single core. You can go up to 6. Again, in the case of PHP applications, you probably don't want to, because as RAM scales up, so does cost. They are directly proportional. So if you can run with lower RAM or lower CPU, then you want to, because those costs do add up. One thing with Lambda billing is from the time that you start executing to the time that you end execution, you are billed for every millisecond of that. Unlike things like Cloudflare Workers, where you're only billed basically for CPU time, Lambda does bill you when you're, for example, waiting on a network response. So you want to try and push those kind of expensive network operations off rather than waiting for them, which has implications in terms of how you build your Lambda functions. Now, there is a free tier, so you're not going to run into trouble on this immediately, but it is something to keep in mind. And it, again, does have implications on how you architect your things, to where basically if you're making a web request to something that's on that's within AWS, then you want to maybe use something that's more evented, where it's like, hey, make this web request and then invoke a Lambda on the back end when that is done, rather than waiting around for it. It's a little bit different kind of approach, kind of JavaScript-y, event-driven. But if you need to save money on your Lambda invocations, which are a bit more expensive than just setting up a server, if you just run it flat out, then that's how you do it. And you can see a couple of links here on other limits that are in Lambda. So, as mentioned, you're billed on the amount of RAM and the amount of time. This is super fine-grained billing. You're dealing with increments of 64 meg of RAM, which is what you set up ahead of time, and milliseconds of execution, which is metered in real time. There are some differences in billing between the runtimes like Python or Node versus custom runtimes like we're dealing with. They do bill for the initial bootstrapping phase on custom runtimes, where they don't for like Python, Node, that sort of thing. But not a huge deal either way. When you set these things up, you do get more CPU and RAM to work with in that bootstrap phase. So back in kind of loading stuff into that phase will help you if you need to squeeze the last bit of performance out of things. Also, Lambda has had ARM CPU availability with their Graviton chips for a bit now. So if you accidentally, say, build a runtime and upload that to Lambda on your new Apple Silicon Mac, as long as you check that that ARM64 box rather than x86, then that function will still run in that environment, even if there's compiled stuff going on. So one other limitation on Lambda is you don't get internet access for free, at least if you're inside their VPC. Now you can run Lambdas kind of out in the open without access into your kind of internal resources, say databases or that sort of thing. And that's all fine. But if you want to, say, hit a database or Redis or something like that, that is behind the firewall, then you're going to want to run the Lambda in a VPC. And if you run the Lambda in VPC, then if you want to get back to the internet in the same function, then you're going to need a NAT gateway. And that all of a sudden you go from a serverless scale to zero thing to something that costs you, let's see, about $30 a month, something like that, plus your data transfer fees. So the trick with this is if you need to perform something that accesses both the wider internet and internal resources, you split it over multiple lambdas. You're starting to see a theme here. Each lambda does a small thing, throws the result onto a queue, and then the next thing happens to that result. Now, that may stretch out execution time slightly, but in return, you don't have to have the NAT gateway sitting there because you're either interacting with your database internal to your network or the outside internet, and or say pushing something to S3 or pushing something to a queue for the next step. Other thing here is that public IPs cost money. I need to, as of February 1st, I need to actually dig into how that impacts Lambda. That may impact NAT gateway, but it's something to keep in mind for workloads that are still IPv4 and need public access. Now, if you're doing everything within a VPC and using a 10 or 172 address, then you're fine. But if you're dealing with public IPs, and this is a case of not just Lambda, but across AWS, you're looking at $3.60 per month per IP address. So try to economize on those. Now, way back when, there was an issue where in VPCs, your cold starts would take forever. That's no longer an issue, hasn't been for a while. So fortunately, the VPC issues are all around the kind of quirks of networking, because unless you do some really janky workarounds, Lambdas don't have public IP addresses when they're inside a VPC, and that means they can't call out to the internet. Now, we've talked about PHP a little bit on the Lambda side. Let's get into it properly. If you go back far enough, people were shimming PHP onto Lambda by setting up a node runtime and then having that node thing call PHP at the CLI. It's kind of a mess. Eventually, AWS fixed that because they were tired of building a runtime for everybody who was asking for one. Is like, look, if you want to put COBOL on Lambda, then go ahead. Just make sure that it runs inside Amazon Linux. Originally is like Amazon Linux 1 and then 2, and now Amazon Linux 2023. If you can just drop the file system that you need onto kind of that base OS image, then you can run it in whatever language. You can run compiled things. You can run Golang or Rust. And as part of that, you can set up, as kind of a deployment convenience, a runtime layer that has all the files that you need to, say, run a PHP application, and then the set of your files for the PHP app itself is a much smaller upload, and those layers can actually be shared across Lambda functions. Now, this is despite the fact that function URLs exist. The original Lambda implementation is not something where it's like, hey, this is a HTTP endpoint, and it gets served via FPM or the PHP built-in web server. So because Lambda is more of kind of this event-based thing that is more generic than just serving web traffic, the interface for this is more of a, we won't call you, you call us, where the Lambda functions look a lot more like a queue worker than something that serves HTTP traffic. And we'll see that here in a minute. Now, these layers, you're going to have a base of usually like Amazon Linux 2023 or one of the older Amazon Linuxes. And then whether you're dealing with a runtime like Python or Node, or you're dealing with no starting runtime at all, it's always going to be an Amazon Linux base. Then AWS extracts your layers out to /opt, function codes elsewhere, and it's just a file system snapshot. You upload it as a zip file, and then they drop it where needed. Now, you can include library dependencies here, both at the OS level and the application level. Just realize that you're going to have to fiddle a little bit to get the /vendor thing to line up, because it's going to be in a different directory than your actual function code. And kind of an interesting thing with layers is you can, in each layer, you can overwrite the previous ones. And the function itself determines what order those layers get, layered in on. There's something to keep in mind if you are splitting things into multiple layers. In the case of like Bref, you're generally just going to use one. So the lifecycle of a custom runtime Lambda, first off, you start with a cold start. And we'll get into detail on it, exactly what that does in a second. But once that cold start initialization process is set up, which again, you get a little bit more resources on that for lower Lambda sizes, the next step is actual task execution, where you call Lambda, you get more work, you execute the work, you send the result back, and rinse and repeat. Now, Lambda will decide how long your function is going, or your instance is going to stay live. So if the instance hasn't gotten traffic for a while, then Lambda may just shovel it out and say, okay, you're done. You haven't gotten any requests for 20 minutes or an hour or what have you. In addition, Lambda will interrupt you if your request is taking too long. By default, I think the time was like 30 seconds. You can up that to 15 minutes, keeping in mind that if you have a 15-minute Lambda, then it better be doing something reasonable for those 15 minutes, because you are billed per millisecond, and eventually those charges add up. There are also ways of just exiting out of the bootstrap process, and Lambda will catch that and say, okay, well, I guess I need to start up a new instance with cold start. So if your bootstrap error is out, then Lambda will catch it and not just like bill you forever. Now, let's talk about that bootstrap process. So here's where you initialize your runtime. AWS will call a specific binary. It's either /opt/bootstrap or /var/task/bootstrap. Either way, it'll check in both places. And once that starts up, then it's kind of the ball's in your court to and you'll get environment variables that you'll want to then pass to the handler function to actually run things, because you're not necessarily, well, the environment variables within a function invocation, you're not going to see those come in on a request by request basis. Those are set when your function is set up, and those are provided once when the function starts executing. So you want to push those environment variables to wherever you need them. They are available throughout the execution of the code, but that request that is coming in, that Lambda is serving, is not necessarily, well, it's just not going to have those environment variables built into that request. Now, if you have an issue kind of setting things up, then you actually call out to the Lambda internal API, which there's an environment variable telling you where the base path of that is. And that internal Lambda API will shovel your application out of memory and kind of try again if there's an error initializing. That's the right way to do it. If things fail for other reasons, then it will exit out, but this is the way to make it do it quicker. As mentioned before, initialization stage does run faster on smaller Lambda sizes. So if you got heavy work to do, then you can do it here. Now, once you're bootstrapped, the next thing that you do is you say, hey, I'm ready, AWS, give me some work. And you'll get a request ID back. You will get the actual task data in the response body. Now, this task data is JSON encoded. If this was like a post request from somewhere, then there's actually some double encoding that goes on. There's some configuration that you can do around that. But keep in mind that the response, you may need to JSON decode multiple times in order to get the payload that you wanted to work on. Now, once you're done processing whatever that request was, you post back to that endpoint. These links actually link to the correct endpoints in AWS documentation, so you can kind of build this on your own. And you'll take that request ID, put in the URL with the response in the post body, and depending on where you're pushing to, that response body is going to be different. So if it is a web response, then, for example, the function URLs thing that I mentioned earlier, there is an expected response format for that to properly set status code and headers. You can kind of cheat with that with some defaults of like, oh, I'm just going to send the response back as, whatever blob. AWS will do kind of the correct thing with that of, setting some content type headers and such, setting the response code as 200 and then just handing the body back. But if you want more control over that response, you want things to process consistently and correctly, then you'll need to read the docs on what a given service expects back when in a response when it's called. Now, there are some that are calling your service asynchronously, and in their case, they kind of don't care because they're expecting, for example, in what we'll show later, we're responding to an S3 upload by sending an email out. And that email send is not the response to that Lambda invocation. It's just making another API call. And in that case, the response doesn't matter. But in the cases like serving web traffic, then the response format does matter. And it's not just like, hey, echo a thing out. Like if you echo a thing out, it's going to go into your logs and then you'll have it in logs, and that's great. But it's not going to get your response. If you want to handle some cleanup stuff after returning your response as quickly as possible, you can totally do that between the time that your response gets pushed and you ask for the next unit of work, keeping in mind that you're still going to have that 15-minute deadline or whatever you set, and you're still going to be billed for that cleanup work. So if you wanted to, say, return the response of a web request and then do some background processing within that same Lambda, that's totally fine. Just realize that you're going to be billed for it. Now, as mentioned, erroring out, you can send a post back to AWS saying, hey, this errored and here's some detail, and that'll show up in CloudWatch for that function. If you do standard out prints, then those are going to show up in CloudWatch logs, and then metrics are available in CloudWatch, and those CloudWatch metrics are kind of in that control panel that you use to fiddle with the function. There is more detailed telemetry available. Lambda released a telemetry API, I think a year or two ago now, that won't show you like function invocation body or results, but will show you a lot of other metrics around that you can you can then push into something like Datadog, or you can have your own kind of telemetry connector that's basically operating over HTTP. Now, if you don't want to fiddle with getting your runtime exactly correct, see my previous example of like, hey, why doesn't my function run? There's some like shared object here. It's probably like a Amazon Linux 2 versus 3 issue. If you have that issue, then you can also upload a Docker image. And that also allows you to push a lot larger runtimes and images into Lambda because the standard function limit is like 250 meg. But the trade-off here is you don't get function URL support, and things are a bit slower to spin up. Also, just because you have a container that serves HTTP doesn't mean that Lambda is going to use it. You still have to use that same runtime API as before. Now, there's this runtime interface client that kind of makes things a bit easier to set up, but that is language specific. There isn't one for PHP, and the bootstrap code that I'll show you in a minute works just fine inside a container as well as outside. Now, if you want to test that container locally with the weird way that AWS sets things up, there's the runtime interface simulator. Previously, well, actually, I was going to get off on a tangent on runtime interface client that they used to not support the newest version of Node. They fixed that. It runs properly now, so we're good there. Runtime interface simulator is Go binary that you throw into the container, and you set that as the entry point, and it will basically expose the same sort of interface that you would see within the actual Lambda production environment, so that you can test that kind of request work unit setup locally without having to push everything to Lambda in AWS every time. Now, I've got some theories on exactly what this looks like from AWS's side. These are not verified, but take this as you will. First thing is, when a function call comes in, first thing is checking whether, hey, is anybody waiting for work? The thing with those function kind of work unit request HTTP calls is AWS will pause execution of your Lambda and basically block freeze frame while there is no work left to do, which means you need to make sure that there's not a timeout on that request, because it's not a polling thing. But if something's got that request open or waiting for work, then we can skip the cold start. If we are kind of scaling up from 0, then the first thing is we pull in the layers and function code or the Docker container, then run the either container entry point or the kind of by convention bootstrap file, wait for it to actually call the task request API or to fail. And if it fails, then you're going to try. You're not going to try again. It's just going to kind of fail out. But if it succeeds, then it's going to call the API endpoint, and then AWS is going to respond with whatever event triggered Lambda in the first place. And then it's going to wait. And eventually the Lambda is going to call the invocation success endpoint or the failure endpoint. And that's kind of the end of that part of the life cycle, or it's going to time out. Now, with this, I've talked long enough. Let's actually take a look at a little SpongeBot thing is what I like to call it, where it takes an input and then randomly capitalizes it and sends it back across the wire. Now, the cool thing with AWS is you have all these services that you can duct tape and popsicle stick together. In our case, we've got SES, which I did all the domain verification stuff for a while back, so it'll actually work in this particular case. SES pushes to S3, S3 triggers Lambda, and then Lambda actually pulls the email from S3, parses it, capitalizes things, and then sends a reply back via SES. Now, you might be wondering, wait, I told you a few minutes ago that there are your web requests that you make cost time and therefore money, and it looks like I'm making 2 web requests here. Right. So the SES API integration for Lambda only gives you message metadata. It doesn't actually give you message content. Now, that's fine if you're like running a kind of janky spam filter or something like that, or maybe some routing logic or such. But the heavy duty work of actually parsing message content, you don't get that in your direct SES to Lambda integration. So similar to something that I've done with kind of other projects where we're processing email, the first thing that you do is you push your messages to S3. That's a well-trodden path for Lambda or for SES, really standard stuff. Then you set up triggers on the S3 side to say, okay, when something lands in S3, then do something with it. So let's actually take a look. I'm going to do this, and let's actually take a look at some code here. There we go. So from a actual execution perspective, this is rather simple. The first thing that we'll do is we've got a few things that we need to set up to call to AWS. We set up those clients. This code will actually respond to one of kind of 2 event types. One would be calling this something similar over HTTP. One would be calling it via SES, or rather the S3 upload from SES. In this case, we're looking at this dispatch S3 upload function, and it's going to grab the file from S3. This event thing, remember, we're parsing JSON from the response from the invocation request endpoint, and it's got a lot of nesting in there. Parse that out, grab the file, parse the raw email file, and then reply back and recapitalize that content. Don't do anything with the subject because that's going to break threading. This handled email from whatever was subject, that's going to show up in the logs. On the API side that we'll get into later, it's a lot simpler because we're just recapitalizing things and sending a response. Note that I'm setting the status code thing here. This is consistent between the API gateway, at least the newer version, and function URLs. So AWS did something right there. And the response body is another level of JSON encoding in there. We actually JSON encode this, and I'll show you that in just a second. We have this lovely while true loop where we're submitting the result of this get task call after we run it through our actual code. So let's actually take a look at what that runtime looks like under the hood. First off, we have our Bootstrap thing here, and it's just opt bootstrap.php, no big deal there. And what that looks like is this. So first off, I am actually throwing some stuff into logs, but I'm not going to give you session token or access or secret keys because I don't want to own myself. And then we've got this environment variable of Lambda runtime API. That's where we send those requests to. And we do set an exception handler here, so we are handling failures the correct way. And it's just a bunch of HTTP requests when we fail or succeed or want to get a new task. The Lambda API base doesn't change, and this URL structure does not change either. And these are requests that are simple enough to just use file get contents for rather than something like curl. If you wanted to use curl, you totally could, but this is a little bit simpler. So we've got failures. We've got this get task thing that, again, we've got a long timeout here. 30 minutes is plenty enough because you're going to get kind of kicked off of Lambda if your function is idle for too long. We do get some functions. We do get some headers back that, for example, show us a X-ray trace ID, which that helps for kind of AWS internal metrics. And then we've got the actual request body in that response. So as mentioned, you may have multiple layers of JSON decoding here. And then once you're done with the task, you submit it. It's just a bunch of API calls. And we're doing a little bit of header magic here. There used to be a requirement that you base64 encode everything and shove it in JSON, and there's been some more flexibility added in Lambda as time has gone on. So that is the entire Bootstrap thing. Obviously, Bref or something like that has something that's maybe a little bit more full-featured, but this gets the job done. Now, the thing with building with Lambda is you're going to deal with a lot of duct tape, baling wire, and popsicle sticks. So the first thing that I had to do here was, and this is in the README for this repo, you go to simple email service, you go to email receiving, you set up a rule set if you haven't already, and I have a email address for this. You can totally email that if you like. When things are sent to that email address, then they get pushed into S3. Then on the S3 side of things, you have that bucket, and then you actually configure the Lambda function to respond to things in that bucket. So you'll note I have two triggers here. One is for S3 uploads, and in that case, it's just on the anything that is created, because that'll be a wide enough net to catch SES emails. We have the API gateway one that we'll talk through in a minute. One other thing you'll need to do is give the Lambda enough abilities to do whatever you want it to do. In the case of the API gateway example, we don't really need to give it anything. In the case of the email processing example, we need to give it the ability to both read from S3 and to send emails. The specific IAM role or IAM permissions for that are listed in the associated repo. Now, if you wanted to, you could have this kind of test thing in here that you can set a specific event up, and that would run things without having to just like hit the API or send the email or whatever. Let's see what happens if I do this. Let's do that. And we've got a bunch of headers and stuff here. And actually, this is likely not going to work because, oh, actually, I know this is not going to work because you'll notice here that there is no actual body to this. There's a whole bunch of headers, and there's a from information, envelope information, but the body of this email is not here. So you would actually have to respond to an S3 upload, which is something like this. And you would still actually need to go grab the file. Now, the nice thing about these templates is you can kind of see what format AWS is expecting you to conform to on taking those requests and actually doing something useful with them, rather than just having to like wire things up and then call it and then realize that, yeah, that's what the format is. So we go back here, got monitoring on when invocations are, like I tested this earlier. Concurrent executions, we were never doing more than one thing at once. And then you go down here and you've got logs on how long things took and just generally what happened on those calls. And you can hop into a given invocation and see further detail, and then actually see logs for each as well, which it looks like you would have to step into CloudWatch to actually see, which we will do now. Like, look at this. So those are some logs. Actually, let's actually see this in use. I'm going to throw this onto another screen. And do this. Do that and close that and move that over there. And in a second, I'll get something back. So if I refresh that, this does take a little bit of time to come back. Okay, there we go. So we now have our response back on the email side of things. So One thing I didn't point out earlier is this layer here that actually has a PHP runtime in it. Says compatible runtime of Amazon Linux 2, because this is actually the older one that I know works. So that's the nice thing about version layers is when you screw up the new one, then you can go back to the old one. Those layers are visible here, and you can upload a new version just by either posting a zip file or by pushing things from S3. So that is the email side of things. Next up, let's take a look at the API. So as mentioned, we have the API gateway set up. This is a bit simpler code. Let's see where we do that. And in this case, I will actually set up another endpoint here, another API entirely. I have one from earlier. We'll do another. So I'll do HTTP API, REST API. Don't touch that. It's more complex than you need. And we'll add the Lambda integration here. And can just use the default resource path of / method of any is fine. And hit the create button. And if we go back to APIs here and SpongeBob merge and this, let's see if we can find, I have to hit the deploy button. Yeah, no, I don't. I just need to find where my actual HTTP endpoint is. It's regional. This. That's correct. Okay. The fun thing here is it was obvious to me earlier where this endpoint was, but it's escaping me now. Let's actually look at Lambda. So we've got API gateway here. There we go. That's the API endpoint. Let's go there. All right, so we've got it prompting us to do a message, and we do this. And we get that response back. So one other thing we can do here is, let's see if we can set another one of these up. To use the function URL. So we're going to do AL2. That is correct. That is correct. Enable function URL. And we don't need anything there. You can create the function. Set up a trigger. Oh, actually, I don't think we even need to that. Let's grab that layer that we added to the other one. And use the version that I know works. And then upload our code. Which I don't think that archive.zip is the correct one. Let's make sure. Okay, that's the correct one. Save that. Vendor directories are large. And we have that function URL there. Let's see what happens when we hit it. All right, so that actually worked. This little bit of info here is just a Chrome extension that I have. So we've dealt with function URLs. We've dealt with APIs. Getting a little bit ahead of myself here, but the nice thing with function URLs is if you want to authenticate them, then you can use the same kind of IAM AWS function or AWS signature thing that other AWS services use, and it'll just work with that. And you can kind of have fine-grained permissions similar to what you would see with any other AWS service. So this one, we'll see whether this actually will work. So if we go back here to SpongeBob here, actually let's create another function. Actually ECR, let me see if I have my container in here from a while back. Don't. For the sake of time, I'm going to skip that. I can hang around later and demo that, but I realize I'm kind of over on time here. But if you look at what the Docker image actually is, Docker file, pretty standard PHP thing. We do set a task root here so that we call things in the correct places. And you can set and then the command is just kind of standard entry point there. So that for this repo, you can actually bounce between the function version of the code where you're just uploading files and the container version of the code, and they both perform basically the same way. As mentioned earlier, you've got that Lambda RIE for testing things locally. If you need that, then I just did things a lazy way rather than with build targets. And if you need it, you uncomment the architecture appropriate version of that binary, and then tell the RIE to wrap your actual bootstrap file, and that's all you got to do there. And then it'll serve on port 8080 and kind of behave like the standard Lambda API. So with that, realistically though, you probably want to use Bref in a production environment because it's not using my hacky code that I can't even get the new version of runtime on. The actual runtime that I'm using for this is copying off of Bref's work. Theirs works, mine will soon. They have all the proper build scripts for building a PHP runtime that behaves correctly in Amazon Linux. It's just bref.sh, and they use serverless framework under the hood, so they're not doing all the work themselves, but actually works pretty well. We'll see a demo of that in a second because that is actually a short demo. If you're using Laravel, then Vapor has stuff like Bref does, but a whole lot more in terms of an actual UI on things, and costs $39 a month. But if you're fine with the limitations of not having any of your queue jobs or requests lasting more than 15 minutes, it's a pretty solid way of deploying a Laravel application, or so I'm told. So let's actually look at this in Bref. If I hop over here, go to a larger screen, and then do this. I've already npm IG'd serverless framework, and I've already Composer installed. Let's just do that again here. All right, we're good. We run serverless deploy. While that is running, let's actually take a look at the underlying configuration file here. So it's a nice quick file of you tell serverless to use Bref as a plugin, you tell Bref which runtime to use, you tell Bref the timeout. Note that API Gateway has a much shorter timeout than Lambda does, and I believe function URLs has like a timeout of 60 seconds. You tell it, hey, this is HTTP API, just pipe everything to here, and then at that point, you kind of just use your application as it would be in a normal PHP FPM sort of deal. So if we look at fpm.php, we get our super globals there, and it just kind of behaves normally. CloudFormation is taking a little bit to set up. That is the kind of disadvantage of using something like serverless framework, because it's doing a whole CloudFormation stack. It may be the right way to do things, but it is not necessarily the fast way of doing things. And I guess US East 1 is misbehaving right now, so this is taking a lot longer to demo than I would expect. Earlier today, I think it ran in like 30 to 60 seconds. But, okay. Now that I've started shaming it, we do have a URL back, and that gives us a, it's just an API gateway, and let's set that up. That was a cold start. Let's do, and that all works. And at this point, if I go back to, let's see here. If I go back here, actually, I think that's probably in a different account or something like that, but we'll just drop this out for now. So with that, that is my presentation. Thank you for tuning in. I will now take a look at the scroll back in chat to make sure I have not missed any questions. As mentioned, I will make sure that that runtime that is in GitHub is working properly and properly documented, so that y'all can easily pull down this repo, play with it yourselves. And yeah, Thanks so much for your attention.
My background is not working, but I will join you up here. Can you explain what a layer is? Because it seems like it's not an AMI, but it's not a it's just a
It
Lambda
is, so let
container.
me back up to where I talk about that here. If we go back to, here we go. So it's literally a set of files that get unzipped into OPT. And you can define the order in which they are unzipped if you have multiple of them. You can have up to 5 set up in a Lambda. So for example, if you have like a runtime and then maybe your contents of /vendor, each of those can be a layer. There is some overhead to deploying layers versus just everything in a single package, but that overhead is mitigated by the fact that there's less to upload to Lambda, and so it's kind of a trade-off. But generally, you put your runtime in the layers, and then your own code in the Lambda function, and then include that layer of the runtime, and that's how Bref does it.
So like once you create the layer, like can you call it from like a CloudFormation or from other auto magic?
Yes. Yeah.
Okay.
Like when you're setting up a Lambda, like if you go back to the UI where it said like, hey, give me this layer, add this new layer, like all of that's API calls under the hood. And when I set things up with Bref just now, that was using the public Bref layer under the hood. So theoretically, what you could do instead of like rebuilding the runtime that I've done is you use the Bref public layer and then add in your own little custom bootstrap on top of that, and it will overwrite kind of in the order that you specify those layers.
Cool. That's pretty neat. That's something new about Lambdas that I learned. That is interesting. Should we bring some other people up on stage? Everybody, give me a thumbs up if you want to come on stage. All right. There we go.
And we do have both a MergePHP room or channel in the PHP UG Slack, as well as you can find me in the PHPC Discord. I'll post from my Mastodon account, and I'll make sure it gets reposted from the MergePHP one when I have confirmed what the issue was on the newer runtime version. And at that point, like worst case, you can pull the like one commit or two ago and upload that as a layer. In best case, I'll get that newest one fixed and post on it, and then again you can play with this. Let me put the links back on the screen here for the repo.
Awesome. Any other questions for Ian? Thank you so much for the talk, Ian.
Sure.
So if you go, somebody's asking for a link to the thing. So speakers. Hopefully my short URL, yes, it's still working. All right, here's the link, mphp.io/speakers. Sweet. We haven't done a Vapor talk. I think that would be fun. And that I was looking into the AWS SAM thing as well. I know, Ian, you said you're not going to talk about it, but
Like
possible
it's
talks in the future.
the nice thing about the Lambda RIE is it gets you quite close without dealing with SAM for the containerized side of things. Now, I'll bet that RIE would even work if you just ran it locally outside the container for things that are just like the file system based stuff. But yeah, I'm not familiar with SAM because I haven't had to use it. Like serverless kind of provides an alternative, and Bref on top of that provides an alternative where you don't really have to use SAM.
SAM seemed like it was a recent thing, but maybe it's been around for a while.
Yeah.
AWS likes to come up with new ways to repackage CloudFormation.
Yeah.
How can we take CloudFormation and jump it all up together and then combine it to make new things?
Yeah. All right.
All right.
I'm gonna drop my screen share now.
Any winners, Chris? We got one.
Yes.
Good.
Aaron, I'll get an email out tonight or tomorrow.
Good. Everybody doing good? Doing well? It's like 70 degrees in Texas today. I don't know what's the weather like where you guys are.
We've had nonstop snowstorms here. Got about a foot on the ground.
Nice.
One snowmobile this weekend.
Hey, that's fun.
It's 40 here. It's kind of nice.
Oh, I think I'm going to hop out so that I can fix that runtime issue, and I will see all y'all online.
All right,
Thanks so
sounds
much,
good.
Ian. Appreciate you covering this month for
All
us.
right.
Thanks, Ian.
Yep.
Thanks, Ian.
Thanks, Ian. Congrats on the new job, Bobby.
Thank you, sir.
I feel like I've seen that company before. Are they Boston-based?
It's like someone works there.
Huh?
He's working with me now.
Oh,
Yeah.
okay. That's probably where I've seen it before. All right. Well, I'm sorry, Bobby.
Ouch.
Zach still with you, Mark?
Yep, Zach's still there. He's now engineering manager.
Oh, nice. I need to get back in touch with him again. It's been too long. Tell him I said hi.
Yeah, we do.
Been working with him too.
Cool.
Just thinking the other day, we need to meet up for a beer or something, Chris. I feel like I'm in Atlanta twice a month, and I never hit you up.
Okay. Yeah. Let me know next time you're heading this way.
Yeah, I will. I'm actually no travel for a couple of months, I think. But next time I travel, we'll find something around it.
Cool. Yeah, I don't like kind of randomly appear in Columbus area very often, if ever. But I'd see you more often. But yeah, keep me posted when you know what you're doing, and we'll definitely make it work.
You mean you don't want to come visit the military base or the the Five Guys and the Target and stuff?
Well, I could, I guess. It's like a 2-hour one-way trip. For you, I'll do it. I'll make the trip.
Atlanta's always fun to visit. I think Ben should be headed that way.
Yeah, it's definitely my responsibility.
Yeah. All sorts of good food in Atlanta, from what I remember. But they got to have barbecue or something, some good, little, things to discover. I found a new chicken place that in here in Austin.
In Austin? What, like hot chicken or what kind of chicken?
Just grilled chicken and tacos and just like all sorts of it's like northern in Spanish. I don't know, pronounce it very well, but yeah, I'm like, Instagram is so dangerous. I don't know if you guys are on, have a lot of food things on Instagram, but the algorithm has definitely figured me out.
Yeah, I get so many just smoked meats or whatever videos. And I've started making a list of places in Atlanta because I'll get all these videos now on Instagram of Atlanta places.
Oh, you can bookmark things on the Instagram now. I think that there's a way on the right.
Oh, that's good to know. Okay.
I sent my friends so many DMs that I'm like, they're like, please create a list. So what are you gonna say, Chris?
I was my more recent restaurant experience in Atlanta is what will the kids eat. So that's why I'm less prone to show up in Columbus or know all the hot new spots. It's Chick-fil-A and stuff like that. Whoever's got chicken fingers, that's where we're
Yeah, I was gonna say a lot of chicken tendies going on, huh?
That's my unfortunate recent experience. I can't help you out with the Atlanta restaurants too well. There's a few nearby, but I'm in northern suburbs, so it's a little different than the midtown stuff. But it's all good.
That's where I'm at with home food. It's like, what can we make that we can feed to the kid right now?
Yep.
I haven't graduated to restaurants with the kid yet.
Yes, what do we have that they will eat this week? As it's gonna change next week.
But I took my 5 boys out to eat. I don't do it very often, but we did. Went to an Indian restaurant, and they actually liked it. It was good. It was good experience. I'm not worried about it, but it went really well. It's a Christmas treat.
That's the one restaurant I took my kid to so far was an Indian restaurant, and he liked it. It was surprising because we've never given him Indian food before.
Now I want some butter chicken.
Oh yeah, that's a good one.
Did you say you have 5 boys?
5 boys, yep.
Wow, that's a lot of boys. That's a lot of.
I do a lot of outdoor activities. They all went sledding at the park nearby.
Nice.
They took oldest got a snowboard for Christmas, so he's trying to do 180s off of it.
That's fun.
They're all watching them sledding and stuff.
I hope your deductible is low.
I know right where the Instacare is. I've been there a handful of times.
Nice.
Stitches, broken arms, whatever.
That's how you learn, right?
Yep. Unfortunately.
So somebody in the chat asked, how do they submit a topic for a future meetup? Oh, you responded. Okay. Sorry. I missed the response. Yeah, definitely please submit. We would have loved to get new speakers. Ian would like a break every now and then.
Yep. Do we have an organizer? 2 weeks. 2 weeks. We have organizer meeting. Reminding myself. All right, gentlemen. Shall we call it? We'll get some food.
Yeah. Good to talk to everybody. Good to see you all again.
Yeah, it's good to see all y'all.
Yes, everybody. Happy New Year.
Good night.
Later.
Good seeing everybody. Happy New Year.
Take care.
Bye.